Greetings everyone. Today we are going to learn another derivation from electric charges and fields. Okay. So the derivation is derive an electric field at a point on the equatorial plane. So due to a electric dipole. So before going to the things, we'll just see the basics. What are the things we have for a dipole? Since we know that a dipole, it is made up of two charges plus q, and it is separated by another charge minus q. And if the separation between the two charges is 2a, okay, then the dipole moment is given by q into 2a, charge into distance of separation. Okay, and the direction of the dipole moment is always from minus to plus q. Okay, it is always from minus to plus q. So this is the one basic concept. And next one is electric field. The formula for electric field is given by 1 by 4 pi epsilon naught q divided by r, where q is the charge, r is the distance. And the next basic concept we required is a resolution of vectors. So the resolution of a vector, see if there is a vector which is actually lying in a x and y plane. Okay, there is a vector which is actually lying in a x and y plane, and if it is making an angle theta, this will be a, the x component can be written as a cos theta and y component can be written as a sin theta. And next here we are talking about equatorial plane. See, generally if there is a line and if I measure something perpendicular bisector along the perpendicular bisector of that line, then we call it as equatorial. So equatorial plane means we are measuring it across a plane of these things. Okay, so this is one of the most important 5-marker derivation. Okay, 5-marker derivation which has been repeatedly asked in a previous year PU, Karnataka PU question papers also. So now, keeping all these basics, we will do a derivation now. Okay. So for that, let us consider two charges plus q and minus q. Actually, it is a dipole which is separated by a distance 2a. Okay, it is separated by a distance 2a. And from the center O, let us assume that plus q is at a location A and minus q is at a location B. From the center O, okay, plus q is at a distance A and minus q is at a distance A. Okay. So the direction of the dipole moment is always from minus to plus. Therefore, this is the direction of the dipole moment. So now let us assume a distance from here to here. The equatorial distance from the center is, let us assume it to be r. If this is the point where we are supposed to calculate the field, electric field. So in order to calculate the electric field, see, a magnetic field can be identified and calculated by the force experienced by a magnet within a magnetic field, right? Similarly, we have to place a test charge to identify or to calculate the electric field in that region. Therefore, the test charge value is plus 1 coulomb. I'm extremely sorry, plus 1 coulomb. Let A be this is the A distance and this is the R, and therefore this is a perpendicular bisector. Therefore, the angle here is 90 degrees. And let us assume that it is making an angle theta with respect to horizontal. Therefore, since it is 90, this makes a right angle triangle. Therefore, since it is A and this is R, the distance from A to P, that is the distance between plus Q and plus 1 coulomb, a test charge, E can be written as under root of R square plus A square. Similarly, here also, the distance is A and the distance from here to here, it is 90 degrees. It is the angle. Therefore, the side of this is also having a same value, that is under root of r square plus a square. Therefore, this makes an angle theta. Since I have placed a test charge plus 1 coulomb at a point P, therefore, here we are supposed to calculate the direction of the field. How to calculate the direction of the field? Since this is plus and this is also plus 1 coulomb, and electrostatic force is a central force, it always acts along the line of the action. Therefore, since it always acts along the line of the action, okay, so this plus q and this is minus 1. Therefore, it will be repulsive in nature. Therefore, due to the force on due plus q on plus 1 will go in this direction, I will name this electric field as E plus. Similarly, the charge at P is negative minus q and the charge at P is plus q. Therefore, it will be attractive in nature and the electric field force is a central force. Therefore, it acts along the line of the action in this direction. Sorry, I call this as E minus. And this is the theta. Therefore, exterior angle, theta plus theta, it will be total angle will be 2 theta. But we'll do a simplest way. We'll consider x-axis and y-axis for this point. So first, let me assume an x-axis here. Since angle theta is made with respect to the line joining AP and the horizontal line, here also this line is extended here and this is parallel to this. Therefore, it always makes an angle same as that is theta. Here also it is same case. Here also it makes an angle theta. And now if I plot a y-axis for this, see here, E plus is lying between y-axis and x-axis in this plane. Therefore, this will become E plus, since theta is here, that component will be cos theta, since electric field is a vector. Therefore, this will become E plus sine theta. Similarly, this is lying inside this plane. Therefore, this will become E minus cos theta and this will be E minus sine theta. Now, we'll calculate what is the magnitude of E plus and E minus using a formula. E is equal to 1 by 4 pi epsilon naught Q by R square, Q by R square. Therefore, E plus is equal to 1 by 4 pi epsilon naught Q is plus Q. Therefore, Q divided by R square is given by under root of R square plus A square, the distance between them, whole square. Therefore, this will become 1 by 4 pi epsilon naught Q divided by R square plus A square. Am I right? Square and square root gets cancelled. This is the value of E plus. And similarly, E minus is equal to 1 by 4 pi epsilon naught Q divided by same Q. We are not considering the negative signs here because we are considering the directions directly. Therefore, minus Q and these are attractive and the distance between them is same as the distance. Therefore, I'll write directly R square plus A square. So from this, it is clear that E plus is equal to E minus. Therefore, I can also say that E plus sine theta is equal to E minus sine theta. Am I right? Therefore, since E plus sine theta is equal to E minus sine theta, and from here figure, I can say that these two are opposite in direction. Therefore, they get cancelled. Therefore, the net force experienced by the unit test charge which is placed at point P is E plus cos theta and E minus cos theta. Therefore, the value will be, therefore, the net electric field will be E net is equal to 2 times, since E plus is equal to E minus, I am directly writing 2 times E plus cos theta. Okay. Therefore, since we know the value of E plus and we can write cos theta is equal to adjacent by hypotenuse. Adjacent side is given by, since this is theta, adjacent side is A divided by hypotenuse is given by root of R square plus A square. Therefore, we have now this formula E net is equal to 2 times of E plus cos theta. And we have from the previous figure and things, we are seeing that E plus is equal to 1 by 4 pi epsilon naught Q divided by R square plus A square. And similarly, we have cos theta is equal to A divided by under root of R square plus A square. Therefore, E net is equal to 1 by 4 pi epsilon naught 2 times Q divided by R square plus A square into A divided by under root of R square plus A square. See here, we have this A to the power of 1 to the power of root A is, it can be written as A to the power of 1 into A to the power of 1 by 2. Therefore, if the bases are same, I can add the powers. We know this from the basic school level concepts. 1 by 1 plus 2. Therefore, A to the power of 2 plus 1 divided by 2, that is equal to A to the power of 3 by 2. Similarly, here also have R square plus A square, root of R square plus A square. This can be written as 1 by 4 pi epsilon naught, right? Q, I'm just rearranging the terms, to A divided by R square plus A square to the power of 3 by 2. So this is what we have written, and Q into 2A is nothing but our dipole moment. Therefore, I am just replacing that with this E net is equal to 1 by 4 pi epsilon naught. Q into 2A is nothing but my dipole moment, P divided by R square plus A square to the power of 3 by 2. Now it's the time to write the direction, because we have to write it in a vector form. If you see here, the total net electric field is in this direction and the dipole moment is in opposite direction. Therefore, I can write it as the direction as minus P cap. Therefore, vector E net is equal to minus 1 by 4 pi epsilon naught vector P divided by R square plus A square into to the power of 3 by 2. Now we know that this is because vector A into A cap, sorry, magnitude of A into A cap can be written as vector A. So for short dipole, R is very, very much greater than A. What do you mean by that? We are measuring the electric field at very longer point, at a very high point. So when we are measuring the distance at a very high point, I can neglect the A value, right? I can neglect the distance between the dipoles. Therefore, then it becomes E net is equal to, this will become 0, r square to the power of A is neglected. Therefore, r square to the power of 3 by 2 can be written as r to the power of 3 into 2 divided by 2. 2 gets cancelled because a to the power of m to the power of 1 by n can be written as a to the power of m by n. Therefore, that will becomes here minus 1 by 4 pi epsilon naught vector p divided by r cube. Okay, vector p divided by r cube. So this is the all about the derivation what we have done here. I hope you understood this, and the notes is attached in the you Telegram channel. Since I am doing only for PU all these derivations, I'm not going to discuss the result of this here. I am doing the separate videos for all these things in the upcoming days. Okay. Thank you.